8.3 present value. So what is present value? Present value is the value of an investment or loan on a date before the end of a term. So that sounds super confusing, and pretty much present value is what do I have to invest now? It's basically like we're finding the amount. Okay, so what do I have to invest now, the present value, in order to kick out this amount in the future? Okay, and then future value, the value of an investment or loan at the end of a term. So this is the present value formula. I'm just going to let's take a look at, I'm going to show you where this comes from. So we know the amount equals P1 plus I to the n, okay? And that's to solve for the amount. But if we want to actually solve for this principal, like what principal amount do I have to put in? All we're actually doing is dividing both sides by 1 plus I to the n. 1 plus I to the n. So right now, those cancel out. We have A over 1 plus I to the n equals P. Okay, but we know when we have an exponent in the bottom, we can raise it to the top. Let's go P equals A. We can raise this 1 plus I to the n to the top by making that exponent negative. And we know that from exponent laws. So this is the same formula as the amount formula for compound interest. The only difference is that it's rearranged. Okay, and we have the compounding and then the meaning. Again, we already went over that. And then these are going to be the exact same. A is the final amount, P is the present value, or we called it the principal. I is the interest rate per number, like a decimal divided by the number of times per year, and the n is the number of compounding periods, or the number of years times the number of times per year. So let's actually take a look at these examples. I personally don't often use this. I usually use the normal amount formula, and then I just rearrange. Okay, so Naya wants to have enough money to buy a car that costs $20,000 in 2 years. So what she's looking for is the amount of $20,000. She wants her investment to kick this out, but she doesn't know what she needs to invest. Okay, 2 years. If she invests her money at 6% compounded monthly, so divide that by 12, and we know that she needs it in 2 years, so multiply that by 12. Okay, she's going to get paid out 0.00, I think it's 1. Oh, 5. 1, 2, 0.005. She's going to get paid out half a percentage each month, but she's going to get that paid out 24 times. So you can either try it with P equals A, 1 plus I to the negative n, or you can sub it into the original equation, and I'll do both for this one example and just show you that it comes out to the same thing. Okay, the amount is 20,000. Principal we don't know. 1 plus I is going to be 1.005 to the 24. Divide both sides by 1.005 to the 24. 1.005 to the 24. And we're already P equals, we're already at this step right here. So let's go 20,000 divided by 1.005 to the 24. I get 17,743.71. Okay, if you do it this way, principal equals 20,000, 1.005 to the negative 24. You actually get the exact same amount. So it's your choice which one you want to do, but I would practice both of them in your calculators right now and just make sure that you're comfortable putting this exponent in. Okay, so Naya needs to invest today $17,743.71 in order to have $20,000 at the end of 2 years. Okay, so this might be another way to word these equations where you're looking for the present value or the principal. Okay, so Brittany borrowed some money. Okay, we don't know how much, but just some money at 12% a year. So we know that that's 0.12. Compounded semi-annually, so that's 2 times a year. Okay, so interest is going to be divided by 2. We're going to get paid out 6% twice a year, and then however many years times 2. So after 5 years, so it's 10 times, she paid $13,382.26 to pay off the loan. Okay, this wording, little confusing, but this is what they'll have in the book and in future math courses. Okay, so she borrowed some money, and then at the end of 5 years, what she had to do, she had to pay the loan all at once. So what she did, she paid this amount of money to pay off the complete loan. Okay, so that's the amount that she had to pay at the end of 5 years. So what we don't know is how much she actually borrowed. Okay, so let's do it either way. Let's do it with the amount formula. Amount equals P 1 plus I to the negative n. Oh no, P equals A. See, I never use this. Let's delete this. Alright, P equals A 1 plus I to the negative n. So we don't know what amount she borrowed, but she had to pay at the end. It grew with all that interest to this amount. Okay, so now let's put that into our calculators. Okay, and sorry, remember that that's negative 10. Oh, here we go. Okay, negative 10 on the exponent. So she actually borrowed $7,472.58, which grew to $13,000 in that 5 years, and then she had to pay off this amount. And that's assuming she didn't pay any payments throughout. Okay, and I won't complete this portion of it, but if we did want to use this formula, we would just have to sub in the amount where the A is. Okay, solve for the P, 1.06 to the 10, and then divide both sides by 1.06 to the 10. 1.06 to the 10. Why some students like this one better is because they're not really comfortable with that negative 10. All that means is we're dividing by this much, because that's in the denominator. Okay, and that's it.